Bismillahirrahmanirrahim. Assalamualaikum to all students. Our topic now 6.1 Antiderivative Concept. Okay, for the introduction part, okay, what is antiderivative concept? Okay, a function fx is antiderivative of fx, okay, on an interval I if f prime x equal to fx. Okay, so before this we learn on how to differentiate the function, right? So the function that before we differentiate, we use a capital letter of fx, and when we differentiate the function, okay, we use the small letter of fx. Okay, now there is some simple explanation about the concept. Okay, so now we have here fx. Okay, let's say we have a function of fx, and when we differentiate the function, okay, we get the small letter of fx, and this is what we call it. When we differentiate the function, we get fx, and this is the derivative of fx. Okay, when we start from here and then we back to the original function, okay, so we apply the integration. Okay, this is what we call as antiderivative concept. Okay, meaning that antiderivative of fx, we are trying to get the original, okay, the original function here. Okay, alright, so for the topic differentiation, this one we learn from 5.1 until 5.5, okay, 5.6, alright. And then for this one, okay, integration, meaning that we are trying to get, okay, the original function by using integration. Okay, this is start from topic chapter 6 and until 6.1 until 6.5. Okay, therefore we can conclude that, okay, antiderivative we can also call as integration. Okay, this is the simple word for the antiderivative. Okay, this is what we call as, okay, the indefinite integral. Okay, we use the symbol of this one. We call it as integral sign. To indicate that the operation of integration is to be performed on some function of fx. Thus, okay, so this is how we write, okay, the integration. So when we integrate this one, all right, okay, one more thing, this is very important. Okay, this is what we call as the variable indicator. So meaning that if you want to integrate the function, right, so you have to look at the variable indicator. Okay, if you integrate other than the letter of x, that one become constant. Okay, so let's say if the function now the indicator shows x, so meaning that if you have other function like a, z, or y, okay, this one consider as a constant. All right, the integration, so this one we call as integrand. This one is a constant of integration. Okay, using this notation, okay, the notation above, the examples that I show here can be written as the integral of, okay, 1 dx. Okay, if you integrate this, we get as x plus c. Okay, this is the answer. And this one another example, the integral of, okay, x dx. Okay, the answer is this one. Okay, what I want to show here, where c, the value of c here and k here are arbitrary constant. Okay, this is the pattern on how we use the integral notation. Okay, this is the important part for the topic 6.1, where we have to understand the basic integration rules. Okay, we have here in total 6 rules of integration, and you have to understand one by one. Okay, Okay, rule number 1, indefinite integral of a constant. Okay, now we have fx equal to k, where k is a constant. When we integrate k dx, okay, the variable indicated now is x, right? So we have to add x, okay, next to the value k, okay, and then you have to write plus c. Okay, this is constant. Okay, every time you see constant, you have to add x. Okay, below is the example for the integration of a constant. Example 1, evaluate each of the following indefinite integrals. Okay, here we have two questions. Okay, question A, integrate 2 dx. Okay, now our variable indicator is x. And then let's see if what happen if you integrate the constant. You can follow the rules of integration now. Okay, you have to add x. Okay, so the answer is 2x plus c. Okay, why x? Because of you have to use this one. Okay, integrate the function with respect to value with respect to x. Okay, so the answer is 2x. This is 2x plus c. So for the b, integrate pi square dt. Okay, so the answer now here you have to just write the constant and then add t. Okay, because of now our variable indicator is t plus c. Okay, so this is how we apply rule number 1. Okay, now rule number 2, this is the power rule. Okay, the power rule, when we have here fx equal to x power of n, when we integrate x power of n, okay, you have to, x n plus 1. Okay, the power we have to add 1, divide by, okay, this one, okay, bring it down, and plus 1 plus c. Okay, this is the what we call as power rule. Okay, now we proceed with the examples. Example to evaluate each of the following indefinite integrals. Okay, question A, the integral of x cube dx. So now we have here power, right? Okay, we have a power 3. Okay, by using the formula in the power rule. Okay, now we have to understand that. Okay, 3 plus 1 divided by 3 plus 1 plus c. Okay, to simplify this, okay, the answer is x power 4 and bring it down 4 plus c. Okay, this is power rule. Okay, and then question B, we have here x power of 3 over 2 dx. Okay, the step is, okay, x 3 plus 1, 3 over 2 plus 1 divided by, okay, bring it down, 3 plus 2 plus 1 plus c. And when you press your calculator, the value that you get is x 5 over 2 divided by 5 over 2 plus c. Okay, so 2 you can, okay, you can apply this formula. Okay, let's say we have this one, we have a fraction and then we have another fraction. Okay, this is formula where you can just simplify the fraction. Let's say a over b divided by c over d. Okay, the formula is you have to use a multiply d, so ad divided by b multiply with c bc. So we know we apply the same formula for this fraction. So this one is a. Okay, we have no b, and then 5, the value 5 is c, and number 2 now is d. Okay, by using the formula given here, okay, the answer for this is okay, a multiply d, so the answer is 2x power of 5 over 2 divided by bc, since we have no b now. Okay, no b meaning that the value is 1. Okay, 1 multiplied by 5, so we get here 5. Okay, this is how we simplify the fraction. Okay, next we proceed example C. Okay, what the question is the integral of 1 over x power of 3 over 2 dx. So now what you have to do, you have to bring x, okay, bring it up, and then this one x power of negative 3 over 2 dx. Okay, integrate this. Remember the power you have to add 1, divide by 3, negative 3 over 2 plus 1 plus c. Okay, if you press the calculator, negative 3 over 2 plus 1, the answer is negative okay, x power of negative 1 over 2 divided by negative 1 over 2 plus c. Okay, simplify. Oops, sorry, no integral sign. Okay, simplify this. Okay, remember the formula here. Okay, this is very important. Okay, you have to remember. Okay, remember this formula. So now, okay, no b, right? So we have here 2x power of negative 1 over 2 divided by, here we have c, negative 1 plus c. Okay, simplify this. Okay, you have to bring negative, okay, the power of negative down. So the answer is negative 2 over x power of 1 over 2 plus c. Okay, this is the answer. Okay, now rule number 3, constant multiple of a function. We have the pattern like this. Okay, the integral of c fx dx. Okay, let's say we have a constant multiply a function here. So what we have to do, we apply the concept same like in differentiation, where we have to put out c here and we only integrate the function. Okay, the function of fx dx. Okay, now we apply the formula in example 3. So we have here, the question is the integral of 2t. Okay, let's say this one I change the question, 2t cube. Okay, 2t power of 3 dt. So to solve this, okay, we have to put out the constant and integrate only the function inside. So the answer is 2t power of 4. Okay, bring it down 4 plus c. Okay, simplify this 1, 2. So the final answer is t power of 4 divided by 2 plus c. Okay, this is the solution. Now b, we have here the integral of negative 3x. Okay, let's say I change this one, 3x power of negative 3 dx. Okay, so the constant we put it out and then integrate only the function. So the answer will be 3 power of x. Okay, negative 3 plus 1. Okay, the answer is negative 2, right? And then bring it down, negative 2 plus c. Simplify this. Okay, negative we cancel off, and then the final answer is 3 x power of negative 2 divided by 2 plus c. Okay, this is the answer. Okay, never mind, you can, not necessary to put the power negative to the, okay, bring it down, no need. Okay, no need to bring it down. Okay, just let it be, is okay. Alright, okay, these are the examples for the constant multiple of a function, rule number 3. Okay, rule number 4, the sum or difference rule. We have here the integral of fx dx plus minus gx dx. Okay, to solve this, you have to integrate one by one here. Okay, you can see that here we integrate fx dx plus minus and then integrate gx dx. Okay, this is let's say we have more than one term. Okay, you have to integrate one by one. Okay, for the example 4, evaluate this. Now we have here the function 3 x power of 5 plus 4 x power of 3 over 2 minus 2 x power of negative 1 over 2 dx. Okay, to apply the concept, okay, we can integrate one by one, where this one 3x power of 5 dx plus 4x power of 3 over 2 dx minus 2x power of negative 1 over 2 dx. Okay, so we integrate one by one. So this one you have to apply the concept that we learned previous in the previous rules. We have constant, we have to put it out, and then x, okay, x power of 5 dx plus 4 x power of 3 over 2 dx minus 2 x power of negative 1 over 2 dx. Okay, to solve this, we have to apply, okay, this one 3, and then the power of x power of 5, we have to add 1. 3x power of 6 divided by 6, okay, and then plus 4, we have here 4 x power of 3 over 2 plus 1, we get 5 over 2 divided by 5 over 2, okay, minus 2, and then integrate this one, x power of, okay, negative 1 over 2 plus 1, we get 1 over 2, right? Okay, negative 1 over 2 plus 1, this one, the value, this one, we get 1 over 2 divided by 1 over 2 plus c. Okay, we combine all of this, and then to simplify, okay, the final answer is, okay, 3 we can simplify with 6, we get 2. Okay, x power of 6 divided by 2 plus, okay, this one apply the formula that we learned just now, so 4 multiply with 2, so we get here 8 x power of 5 over 2 divided by 5, okay, minus, okay, 2 multiply with 2, we get 4 x power of 1 over 2 plus c. Okay, so this is the answer for rule number, example for rule number 4. Okay, I hope you understand. Okay, where we integrate one by one. Okay, no need to write c many times because of we can just put c at the end of the answer. Okay. Okay, this is rule number 5, very important. Okay, with the integral of exponential function. Okay, if we have here two situations, when we integrate e power of x, okay, dx, okay, you will get the same thing, e power of x plus c. Okay, if you still remember, if you differentiate e power of x, we will get the same thing, okay, e power of x. And then for b, let's say we now have b power of x dx. Okay, so this is c power of variable, constant power of variable. Okay, c power of v. And then to solve this, you have to put like this. Okay, the formula is like this. Okay, copy the same term, okay, for the numerator part, divide by ln b. B is a constant. Okay, so now we apply the concept in example 5. Okay, evaluate okay, the integral of 2 e power of x minus x power of 3 plus 5x dx. Okay, remember now we have a constant, right? Put it out the constant. Okay, we can just let it be. And then we integrate only the function now. Integrate e power of x, you get the same thing, e power of x. Minus x, okay, this is we have to apply power rule. Okay, this one is a different things, okay, different function. Okay, this is c power of v, and then this is v power of c. Okay, where this one we apply exponential function. Okay, number 1 is a exponential function. Number 2, we apply the concept power rule. Okay, where power rule, you have to add 1 for the power. And then the answer for negative, okay, this one, the power we add 1, so x power 4 divided by 4 plus, okay, this one 5 power of x. Okay, this one is c power of v, right? The pattern. So we have to apply the formula for b. Okay, where we have to copy the term 5 power of x divide by ln 5 plus c. Okay, so this is how we solve exponential function. Alright, okay, to prove this, okay, why when we integrate e power of x, we get the same thing. Okay, this one. Okay, we use the formula like this, okay, for b formula. So e power of x we copy, and then ln e. Okay, ln e is actually equal to 1. That's why the answer is the same, e power of x. Right, so I hope you understand. This is very important. Okay, this is the last rule. Okay, rule number 6. We call it as the power rule exception. Okay, why? Because of when now we have integration of x power of negative 1 dx. Okay, normally when we see the power, we add 1, right? Okay, but for this one, we have to apply, okay, the concept of ln. Okay, where we put, okay, this one x power of negative 1 same like 1 over x dx. Okay, when we integrate this pattern, the answer is, okay, ln x plus c. Okay, This is only for the power of negative 1. Alright. So now, okay, this is very important. Alright, so take note. Now example 6, evaluate, we have the integral of 2x plus 3 over x plus 4 over x squared dx. Okay, to integrate this. Okay, this one, the power we add 1. Okay, so means that n 1 plus 1 we get 2, divide by 2. Plus, okay, now we have here 3 power of 3 divide, okay, 3 over x. So when we see over x, we know that this is the power of negative 1, right? So the answer is 3 ln x. Okay, okay, plus, okay, this one we have to change the pattern, so it will be 4x power of negative 2. Alright, and then we integrate, we get the answer is 4 negative 2 plus 1, so the answer is negative 1 divided by negative 1 plus c. Okay, remember now here we have two patterns. Okay, just to show you. Okay, when we have 3 over x, we get ln x. When we have 4 over x square, so we have to bring it up, so it become negative the power, and you have to follow the power rule. Okay, and then this one, okay, the different pattern. Okay, to simplify this one, the final answer is x square plus 3 ln x. Okay, because of we have negative here, negative 4 over x plus c. Okay, this is how we solve. Okay, when we see here we have power rule exception, where we have to apply ln x.